Alrighty, so while we are getting our document up and typing our answer in the box, we should have this document open. This is where we're going to do our notes today. It came from that link, as well as it is also linked in Canvas. So I know last week when I asked how would we prefer to do our notes, some of us said that it was about half and half. Some of us like to write them and some like to type them. So if you are wanting to type them, once you, as we go through the presentation, the information is right here. You can just type in the blanks and you can turn it in. If you prefer to take the pictures because you want to write it by hand, you can stick your pictures here. You can delete the directions and put your pictures in right there, and that's how you will turn that part in. Once we get started, the presentation will be set to allow you to move at your own pace. Some people may finish before we finish, and if you do, the practice questions at the bottom are what your next step is going to be. Now, what we are going to do, these particular questions are more opinion-based questions, but they are opinions based in the science that we are going to talk about today. So when you answer your questions, there can be multiple answers. You just have to back up your answer and explain your reasoning or thinking. Also, I know as we go through, you will more than likely be looking at some different websites to pull your answers from. As you do that, just paste the link here so I can see where you're getting your information from, because people come up with really interesting articles and I like to read them. All right, so we are going to get started here. Let me go to the chat, to the box, and see what we wrote. Alrighty. So our question is, why would you most likely not find fossils in igneous rock? So some of the stuff we said, the skeleton could melt and not hold its shape. You would most likely not find fossils in igneous rock because they are formed through cooling and hardening of magma, and the fossils would most likely melt before the rock hardens. I love that statement. Complete sentence, very well thought out. I love it. Igneous rock is made from magma, and magma is so hot that it could burn the fossil. Correct. Um, because fossils are too old and igneous rock are not that old. Yes and no, because we talked about how rock can transform to different types of rock as long as they go through processes. So you can have really old rock that still gets melted and turned into magma. Igneous rock does not contain any fossils. This is because any fossils in the original rock would have melted when the rock melted to form the magma. That is exactly correct. Good job. Okay. So yeah, we got the gist of it. Good job, guys. All right, so it has now been reset to allow you to go through at your own pace. We are still going to go through it together, so that way I can answer any questions that you have. If you have questions, just put them in the chat and I will answer them as they pop up. All right, so we're going to talk about fossils today. We'll also be talking about fossils next week. This week, it kind of, we're looking at the different types of fossils, whereas next week we'll be looking at how we use fossils to actually date rocks and how we use rocks to help us date fossils. All right, so first we're going to start off with what a fossil actually is. A fossil is going to be preserved remains or traces of an animal, plant, or other organisms that is from the past. The past is not like something that happened last week kind of past. We're talking about past from a bunch of years ago. This is going to be like our prehistoric and our fossils from previous eras. There could be some from the current era that we're in, which is the Cenozoic era, but most of them are going to be older fossils. Next, they are mostly going to be found in sedimentary rock layers. Just like we talked about with our bellwork, most of our igneous rock does come from melted or molten rock. So it would be you probably wouldn't find a whole bunch of fossils, especially intact fossils, in that area. Um, Next, we have can it be? It can be small as bacteria, or it can be a giant dinosaur. It can be microscopic organisms. We could have algae and fungus and all kinds of different stuff, but we could have really, really big ones too, like our lovely dinosaurs. Paleontology is going to be the study of fossils. So just like in English class, I know you guys learn about prefixes and suffixes and root words. We use those same things in science class. So whenever you see the suffix ology, that means the study of. So ology, O-L-O-G-Y, ology. Um, if we see ologist or ist or just is, that's a person who is going to study it. So our the study of fossils is going to be paleontology. The person that studies those fossils is known as a paleontologist. Just like we have geologists that are people that study the earth and things that are in it. Geology is the study of the earth itself. So whenever you see those two words, make sure that we can tell those apart. Fun fact, we have Anna Mary Anning, who is a naturalist. She is credited with finding a lot of these fossils that we are going to find and talk about now. The interesting thing about that is that she is one of the first people who kind of started seeing fossils as what they are, as prehistoric, like remains of past animals and not necessarily of remains of current animals we have. Also, the fact that she's a woman, and if you can tell by her dress, she's not a modern woman. She's a woman that was probably from, I would guess, around the late 18th, early 19th century. And around this time, this is when the women's suffrage movement is kind of going on. Women are being seen kind of differently, because in the past they were not necessarily seen as intellectual as some men. So there were like jobs that women couldn't have. Like you couldn't necessarily be a doctor or certain types of scientists. But we know throughout history we have had a lot of women that have made major contributions to the scientific community, and Mary Anning is one of them. So moving along, we are going to talk about now what are the conditions that are needed for fossils to form. So with our fossils, you have to have a very quick burial. Mainly because I don't, y'all know The Lion King is one of my favorite movies ever. And if you remember, the hyenas were in there talking about food sources and that sorts of thing. Well, you do have animals that eat the remains of other animals. Some of them prefer them when they're kind of decayed, kind of like vultures. There are certain bugs that eat decaying flesh, whereas there's older other animals that prefer to eat more fresh flesh. And so when it comes to animals that die, whether it's because they died of natural causes or if they were killed by another animal, if they're not buried quickly, they're going to be eaten by something else, or they're going to be just decayed from time. So that burial has to happen rather quickly. It can happen by snow. It can happen by sediment and making new rock. It could happen if lava covered those bones. It may melt depending on how hot the lava is, it may melt through some of the bones. It may not. It might form a new rock layer and actually preserve those bones. You also have our layers of sediment that are going to build up over the organism. We talked about sedimentary rock and how those individual particles of shell and dirt just kind of lay on top of each other and make our different layers of rock that will pressurize together to make that sedimentary rock. It's not like super high pressure like metamorphic rock, but it does still have a certain amount of pressure that has to go into that. You also have the fact that it has to be left alone for a long period of time. It takes some time for these fossils to actually fossilize and turn into fossils. So you have to, the bones have to be there in the environment for a long time to actually turn into some of these different types of fossils. It's not like your pet goldfish that was buried out back and now we went and dug it up, a few weeks later and it's a fossil. That's not how that works. Most of the time, the fossilized remains are going to come from hard structures like bones or teeth, and not necessarily those soft structures for the reasons that we already talked about. Erosion and uplifting is also going to help with this process and bringing them to the surface. Y'all know I'm a nerd. We know I'm a nerd. This is nothing new. But there is a show that I like to watch. I think it's called Dinosaur Hunters, and they actually show how they go through and find dinosaur bones all over the world. And so they end up a lot of times finding these bones when they have different earthquakes or catastrophic events that disturb the bones where they are. I know some other classes were talking about Dino Dan earlier today, and how he was talking about some different things with dinosaurs and fossils and all of those sorts of things. So if you are interested in dinosaur fossils, Dino Dan, great show. And so is Dinosaur Hunters. So next we have, we already talked about typically rocks are going to be found in sedimentary layers, mainly because they'll die and then be covered by some layer of weathered rocks, or it could be ice or something like that. Just as a recap, sediment is going to be pressed together. It's also going to be cemented to actually make that rock on top of each other. We also have our fossils are going to also kind of tell us the approximate age of some of the rocks, and as well as some of the other organisms that may be found in those rocks as well. Next week, we will be covering in depth how rocks and fossils are actually how they're actually dated. So this is, I know we've seen this picture before, but this is the picture of the fossil record, and it pretty much documents fossils from all over the world and how they're actually dated. So scientists kind of compiled this major list from stuff that they found in very different places, but they seem to find similar organisms in rocks with other similar organisms, and that's how they kind of created this grand geologic time scale and our fossil record, which is just what it sounds like, a record of our fossils. All right, so now we're going to talk about the major types of fossilization. This is kind of what our week is going to be centered around. We have petrification, molds and casts, carbonization, fossil resin, tar and ice, and trace fossils are our major types of fossilization. So we have, first we're going to start off with petrification. It can be divided into two subgroups, which are replacement and permineralization. Man, that's a hard word. Both of them are going to kind of give you like this organic material that is going to be converted into stone or something very similar. So this is a picture of a tree that has been fossilized. Usually it's petrified when it comes to wood, and if you notice, it doesn't technically look like what you would think normal trees look like that we see today. A lot of that coloring and all that comes from the area that the tree grew in, as well as the area that it was fossilized in. We also we're going to talk about replacement. Replacement is what's going to happen when you have water that's going to dissolve the original hard parts and it's going to replace them with other mineral matter. A lot of times this happens with calcite, silica, pyrite are kind of the big ones. Pyrite is also known as fool's gold. People would dig it up and think that, oh, I struck gold. Really, what it really isn't. It has a much higher iron content than regular gold does, and it's also made more so of mineral content. But it does actually take replace the tissue of the actual organisms with these different minerals, so it would completely end up changing it. It does take a long time for it to happen. It does not happen overnight. It's a real slow process, and usually this is what happens to a lot of the bones, a lot of the shells. Wood kind of goes in here, so that petrification kind of goes in here to make that happen. Next, we have pre-mineralization. With this is where you're going to have groundwater that is going to carry all of these different dissolved minerals. It's going to actually end up getting into the pores and into the cavities, the little spaces that are in the bones, the wood, the shells that you find. Most of the material of the original organism is going to be preserved and kind of encased in these different minerals. It's not going to be replaced, so it's still in there somewhere. The bones, the teeth, shells can be preserved this way. A lot of times the preserving method just depends on where you find it. If it's near a lot of these water sources, the groundwater is just what it sounds like. It's water that runs underground. It's not ocean water. It's not from like a lake or a stream. It's usually an underground reservoir. A lot of times it's an aquifer that will have these minerals that are trapped in there and that will help preserve them. So those are just two different ways that happens. All right, so next is my favorite, are the molds in the cast. Molds in the cast are they are pretty much like imprints of these animals actually preserved in our rock layers. So with a mold, this is where you have an organism that dies, but there's no filling of the cavity with minerals. It's just the imprint of where it was. So you can tell that this was a shell at some point in time. You see the little lines and all that, and you can tell that that was a shell that just kind of got imprinted and is no longer there. Versus this one that is a cast, this is where your organism, when it dies, the cavity is completely filled with minerals. It could be sand, it could be clay, it could also be silt, and they're going to be fossilized over time in that process. So those are ones that you can usually pick up and kind of investigate a little bit more, whereas these are still going to kind of be stuck in our rock layers. Now, have any of you ever heard of Pompeii or Mount Vesuvius? Okay, I see a lot of yeses, a few no's, a lot of yeses though. All right, so for the no's, Mount Vesuvius is a volcano that is in Italy, and it is seated near a city that was called Pompeii. I think it's changed now. It's more closer to Naples, I think, like Naples in that area. But it was called Pompeii, and it went through a volcanic eruption, kind of like this. This is the actual volcano, and it ended up burying pretty much the whole city under lava. And so what ended up happening, some excavators went to the area and they actually dug out a lot of these different ruins that you see in the pictures. And they are, yes, those are bodies. Those are human bodies of the people that weren't, that did not survive the volcanic eruption. So this is like some of the buildings that were in the area. That just kind of were, a lot of them were covered in lava, but they, like I said, they ended up digging them out and were able to still see some of them. These are actual casts of people's bodies that ended up yeah, it is tough. That were actually in the well, not the explosion, but the eruption. So when we were talking earlier about could igneous rock actually hold fossils. Well, somebody, I don't remember who it was, hit the nail right on the head, where it said that if they go through the magma process, then no, because they would be pretty much melted and burnt up in the magma process. But if it was made from the lava as it cools, then it could give us an imprint or a cast of these bodies. So these, at this point in time, this happened, I think, at 79 AD. These would be considered fossils, but they did not come from the making of the igneous rock, from it melting and turning into an igneous. It was an organism that was caught by the cooling lava as it began to solidify. A lot of these, the bodies and stuff that they found, they do not necessarily have like the bones and the tissue and all that stuff in them. A lot of them did kind of disintegrate. A lot of scientists, they go back and forth between, did it happen because the rock was so hard, and I mean, so the lava was so hot and kind of made them disintegrate over time, or is it just because over time that, you know, this is like 2,000 years ago, over time they just kind of decayed and just kind of went away. There, you can do some research on your own, find your own pictures. There are pictures of some bones that were in that area too, because they just were found different versions of them, but they do actually have casts of these bodies on display. This is one of them that they put in a glass box, so that way they could put it on display. But they did also have pottery, and there's other things that that they actually found to show how civilization was in that time. But just interestingness, things I find interesting that I think hope y'all find interesting. All right, so next we have carbonization. With carbonization, it is going to pretty much all of the body parts decay, but it leaves behind this carbon film. A lot of times, like I said, it'll be on the rocks. You can see the details of the leaf. You can see like the veins. You can also see like the bones of the fish. You can see some facial features from the fish and fins and all the rest of that, but you cannot, it does not leave any matter. So there's no bones, there's no leftover fish skin, no leaf, none of that. But it does leave this carbon kind of outline on the rocks. Next is my second favorite type of fossil. This is resin. This is fossilized amber. And for those of you that know who this is John Hammond. We know that he's from Jurassic Park. We know how I love Jurassic Park. And he happened to have this piece of amber that was on the end of his cane. Now, the premise of Jurassic Park, a lot of sci-fi is actually based partially in science, and Jurassic Park is no different. The idea behind Jurassic Park is that which is true, in amber, we do find bugs and you find leaves of prehistoric animals that got trapped in this fossilized amber type tree sap stuff and just got kind of stuck there. If you notice by looking at the pictures of this spider, you could tell that a lot of its body cavities and stuff are kind of preserved. That even kind of looks like an eye, even though I doubt it's an eye on a spider, but it kind of looks like one. But you can see the leaves, you can see all the other parts are pretty much intact for the most part. So the premise in Jurassic Park is that they are able to drill into this amber and pull out this fossilized dinosaur DNA out of a prehistoric mosquito. And out of that prehistoric mosquito, they are going to be able to pull out the DNA from dinosaurs and merge it with the DNA from frogs and create full dinosaurs. Is the premise of Jurassic Park. Now, I don't know about you guys, but I've been bitten by plenty of mosquitoes, and I'm pretty sure that, like, if you're in a gathering with people, that the mosquito that bit your friend is probably also the mosquito that bit you. So how they are actually able to pull all of these different species of dinosaurs out of the DNA from a mosquito, I'm not exactly sure how well that works. Yes, then they did escape and eat everybody. So, still a great movie. I love it. I love the science behind it, and it would be cool if that could really happen, but I'm not totally sold on the science of that actually working. However, this is the part that the science part that it is based in, is that this amber has these fossilized organisms in it that they are able to recover dino DNA. All right. Next, we have our tar and ice. With tar and ice, this is going to be the one of the ones that you can actually find soft tissue in. You may be able to find some in that amber too. Just like I said, by looking at that spider, it looks kind of well preserved. But ice and tar, you are also maybe find some. The tar itself is rather warm. There are tar pits that they could have fallen in, and it literally could have preserved the whole animal as it is. Freezing, we found mammoths' bodies that still had skin, it had hair, it had organs in it, just because it got trapped and frozen in some of the glaciers. So if yeah, it has to be really cold, and there are places that they can dig and find them in, glaciers, those polar ice caps, and all of the rest of those different places. But just like the freezer in your house, if you take some meat that you bought at the store and decide not to cook it right now and put it in the freezer, it'll stay in the freezer and be well preserved for up to a year before it starts to assume that you wrapped it up right and all the rest of that, and you'd be perfectly edible for up to a year, and you'd be fine eating it. The tissue wouldn't decay, nothing would happen to it. It would just be frozen. That same thing is what happens to those animals' bodies that we actually found frozen in ice. All right, and our last one for our types of fossils are trace fossils, and they are fossils that give us evidence that something was there, but we don't actually find body parts or body remnants of these animals. A lot of times there'll be footprints, such as this one right here. You could have burrows like this, where you have animals that maybe tunnel through different areas. And then you could have this, which is fossilized feces, also known as poo, that comes from different animals. You could look at it and they can investigate it and try to figure out what the diets of some of these animals are based off of the waste that they passed. But yeah, there's fossilized poop that people find all the time. But those are your different types of trace fossils. Yeah, this sounds kind of gross. Here's a bunch of people in the chat saying, ew, it happens. It's science. Everybody's got to go. Even dinosaurs, they have to go too. All right, so now we have, we're going to talk about the environment and how fossils work with that. So with fossils in our environment, we know that they would have had to have been in the area if you find a fossil in the area. So there are a lot of mountaintops that they are finding like aquatic animals that are there. That leads you to believe either one of two things. One, either the mountain was way smaller than it used to be, and it was covered in water, and then uplift happened, or maybe a earthquake and pushed it higher to where it is, or that there was enough water at one point in time that it actually covered some of these mountaintops, and that the animals ended up dying up there and getting buried in that, getting buried in the layers of rock and making new fossils. So different scientists have different theories, but it is evidence that helps us see that they very well could have been up there, or that the mountain could have been covered in water. Our next piece of evidence is the idea of Pangea. I know when we were talking about the Mesozoic era, we were talking about how there used to be this massive supercontinent called Pangea. Well, the fossils and the environment also help back up this idea, because if you look, South America, North America, Antarctica, they all kind of look like they could fit together kind of like a puzzle, right? But the fact that we are finding fossil remains on different continents, that at one point, like, you should not be finding tropical plants on Antarctica. It's super cold and can't support that life right now. However, if it was in a different place at a different time, you had animals that were able to roam and walk. They can't fly. They may not be able to swim. So how are they going to get from South America to Africa? There's a lot of ocean in between. However, if they were closer together, or if they were all connected in one major landmass, then it is possible that they could have walked from one side of the landmass to the other. It could have broken up they still would have been there, and then they eventually would have died and become fossils. So that's highly possible, and that is one of the things that they use to back up this whole theory of Pangea and continental drift theory and all of that good jazz. All right, and lastly, we're going to talk about comparative anatomy when we get into our life science unit. But just as a preview, there are certain fossils that are used to compare organisms of the past to organisms that we have today. Um, we look at fish, we can look at horses, we can look at dogs, cats, just about any of the organisms that are here, and we can look to see how much they have changed based off of the remains we find from their ancestors. So those are just some things that we can learn from fossils, our different types of fossils, and some random fun facts from Miss Hewing because she is a nerd. It is what it is. I like being a nerd. So for our assignment today, if you did not finish the notes portion of your document, we're going to go ahead and finish those. Step 2 is that we are going to answer those research questions that are at the bottom. Make sure that you defend your answer. They are not yes or no one-word answers. Make sure that you actually defend them. And then if you use the website to help you figure out your answer, just post the link so that way I can see it, and also so you can give credit to the authors. When you are finished, you're going to turn that assignment into Canvas, and then you are good to go. If you are watching this video and you have questions, please send me a message in my Canvas inbox, and I will answer it as soon as I can.